Okay, what does it mean if x plus 3 is a factor of this polynomial? Or what do we know about that situation if x plus 3 is a factor?
I don't know.
Okay. Help out. X plus 3 is a factor of the polynomial, so what do we know is true? Yeah, okay. So our remainder, actually our factor theorem, means that the remainder is, I'm going to write that word actually. If it's a factor, the remainder is 0. Okay, that kind of implies that we need to go divide. What goes in the box? Yep, it's the 0 of the factor, or negative 3 in this case. And then we get 1, 2, negative 5, and n, since we don't know what n is. Bring down your 1, multiply, we get negative 3, then add negative 1. Multiply positive 3, add negative 2. Multiply, we get 6. And basically we're all this work to solve this little piece right here, where we know that this has to be 0. And so n has to be what? Has to be negative 6. Okay. Raise your hand if you got that. And let's go ahead and check your homework. So grab that, please. I haven't looked yet. Get it out. Oh, you have it out. Huh? I think you're going to get a hand to the face.
Good Lord.
All right, let's check in. Starting on this side. Okay, I didn't show all the division, just the remainder. So A, B, D, and F all have a remainder. And that's the remainder there. Guys, if you get the remainder, then most likely, like if you get the same remainder as me with your division, most likely the rest of your division is correct. But anyway, I starred these two. Why? Oh, maybe. We can go do that one if we need to. Okay, say that again, like real specifically. Why did I star C and E? They are factors. Good. Okay. So it says, like basically which of those are factors. We know it's x minus 3 and x plus 2 are the factors. And there is some opportunity to get confused here between factors and zeros. So I can't write on this right here, but what are the zeros of the factors? Yeah, so 3 and negative 2 are the zeros. Those are factors if I say write in factored form. But the zeros, if I say go graph, you would graph 3 and negative 2. Okay. It says complete the division. So now we have the remaining quadratic. And from that, we can just star factor. I didn't show the star, but this is the two factors you get from the star, which in factored form would be these. What are the zero? What is the zero of this one, of our new factor from the star? Set this equal to 0 and solve it for x. Here I can bring it up. Minus 5, then what? Divide by 2. So what would our 0 be? Negative 5 halves. Or 2.5. Negative 2.5. Okay, please note two things. One, well, first of all, the polynomial was the same on the entire page. Did everybody catch that? You found two of the zeros here. So the way I chose to do it, which isn't the only way, I used one of them to get this quadratic and then factored the quadratic. But if we knew both of these zeros, what degree would we have been at that point? Like if I divided twice? Cubic, I divide once, what's the next degree? Have we ever gone up a degree? If it's cubic and we divide, what's the degree of the result? Squared. Okay, now I divide again. Pick one of these. I divide again. What's the degree of the last one? 1. So if you divided by those in succession, don't miss this. I'm telling you something hugely important right now. If you divided by these in succession, meaning let's say you divide by x minus 3 first, then take that result and divide it by x plus 2, you will end up with 2x plus 5. And now you're completely factored. And you didn't have to do the star. Okay? You want to try that and prove it to yourself? It's kind of cool. Divide by x minus 3, then x plus 2. And show me what you get. Okay? Go. Start doing it. I'm not rare. I'm just like,
so that just means
like let's get on it.
if you can find two factors, you don't have to factor.
All right. We're on fire today, let me tell you. X minus 3, what's the 0?
Positive 3.
Okay, please go divide this. You have 20 seconds. Do it neatly so you can follow what I'm telling you. Just leave it where I left it, mine, right here. Just leave it like that. Okay. Do you see how you got 2, 9, and 10? In your final result, right? Everybody good? Hello? Yes. Good. Okay. Now, we know that x plus 2 is also a 0, or it's a factor rather. Okay? So this is what I'm saying, and I want you to do this when you're trying to break down a polynomial. Look what you can do from here. Just take this one, stick your negative 2, and divide again. Okay, we're using the next 0, negative 2, and divide again. Okay, so what did we discover? Well, this is cool. This is a 0. This is a 0. And then this last thing becomes what? 2x plus 5, which is also a 0, because it was the result of a 0 denominator. Okay? So all of this tells us that factored form, the first one was x minus 3, the next one was x plus 2, and then that one was 2x plus 5. And we didn't have to star factor. We don't have to do the star on this. Now, I'm not saying you're going to do that every time, but it's convenient when you can, right? Okay. Quick check. What was the degree of this first one? Everybody just hold it up on your fingers. What's the degree of the original that we started with? That was third. What's the degree of the 2, 9, 10 if we wrote it as a polynomial? That would be 2. So it went 3, 2. What's the degree of the last one? Do you see how it's breaking down each time? Okay, and that's what we want. We want to break it down so we can get it into the factored form so we can see our zeros. And that's all about graphing and what we call multiplicity. What are the zeros for this again? Let's just make a list. So 3, negative 2, negative 5 halves. Okay? All right. On the back page, here's the check. A, you should have got 4. This is on number 1. C was 27. 7, it was not a 0 because we ended up with the remainder of 25. Interestingly on this, even though we're dividing by a fraction, all of the numbers were whole numbers because they were all multiples of 5. Number 8, yes, it was a factor because we had a 0 remainder. Okay. These ones are the most important problems on the whole sheet. And the reason why is because you are doing that process where you break it all the way down. So it told you that x plus, like to divide by x plus 5, you found that it's a factor because it had a 0 remainder. Now take that resulting quadratic and star factor it, and then here's your final answer in factored form. Okay? Same with each of these. That one you had to do the quadratic formula. Did anybody do that? We will be doing that starting the week after break. So we got a factor. It left us with a non-factorable quadratic. So this resulting 4x squared plus 3x plus 1, you couldn't factor. Only because of one dinky little sign, but it didn't factor. So we had to use the quadratic formula. And guess what? 2 of our zeros were not real. And look why. It's those 2 right there. That one is a real 0. Those 2 that would have come from this crossing the x-axis, those are our non-real zeros. All right. The rest of the time is yours to review for your quiz on Thursday. This looks somewhat like your quiz. It is not like an identical copy of it, but it prepares you for it. It definitely prepares you for Hey, real quick reminder, since I haven't brought this up in a couple days. When can you use synthetic division? If it's just x, right? X plus or x minus. Otherwise, no. Well, x is not. Oh, yeah. Why are you laughing at me?
What? I do.
It seems like it. Do you guys, anybody want a note card for this test?
Yes.
Yes.
Note card. Just a piece of paper? Yep. What do you mean? Can you stop looking at the stuff? I'm using the same
How about a note, sticky note?
What?
Sounds fair.
No,
Sticky note now? I'm thinking like that.
that's diabolical. That's crazy.
We'll save that one for the final.
Hey, the tissue wipe.
You're smart.
Literally like that guy.
That would have been game.
I'm working on it.
Have you talked to the counselor? This should be back. Did you throw your trash on the floor?
Yeah, actually, yeah.